Now consider the introduction of a labor income tax of size tau greater than 0. And the basic idea is that for every dollar that the consumer earns in labor income, it has to pay $2 to the government, and assume for the policy exercise that the revenue is returned to consumers using an identical, and this word is critical, everybody gets the same lump sum transfer tau. Okay, so notice in particular that tau is going to be equal to revenue raised divided by C, the number of consumers. Okay, now question, let's look what happens to the problem of the consumer in equilibrium. So the problem of the consumer becomes maximize over Q comma L greater or equal than 0 of Q minus L squared over 2 theta I plus whatever labor is supplied times 1 minus tau W, because now it doesn't get back all of the revenue, minus PQ, there's no impact, plus tau. Sorry, plus T, the lump sum transfer. And key, this is assume fixed when maximizing. The idea is that when the consumer is choosing its labor, it doesn't assume that it can affect the lump sum transfer that it gets back, because the number of consumers is so large and its size is so relatively small that it's basically a constant. Okay? Now, notice several things. I'm not going to solve the model again in detail. There is just some obvious things. There is no change in equilibrium price. Sorry. There is no change in the Q market. Why is that? Well, look at the problem of the consumer for Q has not changed. The problem of the firm has not changed. So this implies that nothing has changed in that market. And in particular, that P star is going to be equal to 1. Now, what about the labor market? There is no change in firm's problem. And we knew that from the previous arguments, what pins down the equilibrium wage was the labor demand by the firm. So this implies that W star is equals to gamma. Okay, and this is going to be very useful. It's what I was referring to before. There is no change in the equilibrium prices. Now the question is, what happens to the labor supply? So we know that the marginal benefit is L over theta I. We know that the marginal cost, the marginal benefit, I apologize, is 1 minus tau W. The marginal cost is L over theta I. The solution has to be interior, and this implies that, write it here, this implies that the labor supply of any individual at wages W is going to now be 1 minus tau W theta I. In other words, they respond as if instead of the wage being W is wage times 1 minus tau, which is very intuitive since this is the take-home pay per hour worked. And this implies adding up horizontally that the labor supply for the market at W is going to be equal to 1 minus tau W, the sum of the theta i's, but this is just capital Z times the average theta. Remember, this is mean theta. Now, let's look at how taxes, the size of the tax tau impacts the revenue of the tax, raised by the tax. So we have that total revenue as a function of tau is equal to tau times total labor income. But what do we have? Labor income is going to be equal to the labor supply of the market at the equilibrium wage, which is W star equals gamma. If we substitute, we get that this is equal to tau from the formulas we derived in the previous slide, 1 minus tau W C mean theta. So basically, notice that total revenue varies with tau as a function of this tau times 1 minus tau times a constant. Remember also that, that the wage is gamma. Now, if you plot that, you get a curve that looks like this. So this is tau 0, 1, 1/2, and basically that curve in this simple model takes a maximum at 1/2. This is total revenue. This is very intuitive. If you don't tax anything, you don't get any revenue. If you tax everything, people are not going to work because they dislike working and they don't get any wages, so you get zero revenue. The sweet spot is somewhere in the middle. A curve of this type is called a Laffer curve in economics, and it's basically based on the idea that when you start increasing taxes from zero, total tax revenue increases for a while and then eventually decreases. So if the taxes are very high in particular, you may be better off reducing the size of the tax rate, which introduces less distortions, less deadweight loss, and on top of that raises more revenue. Now, the exact point of where the top of the Laffer curve is going to depend on the details of the model. This is a very simple model. We get a Laffer curve peaking at 1/2. In other models, it's below. And in other models, it can be at other points. So don't take the precise shape of the Laffer curve very seriously, but take the idea of the Laffer curve very seriously because it's a very important one. By the way, a quick link with current policy debates in the United States. We are in the midst of an ongoing budget stalemate, and a lot of the debate can be traced back to beliefs about where this Laffer curve is. There are many people in the Republican Party which believe, correctly or incorrectly, that we are to the right-hand side of the Laffer curve and that we'll be better off if we cut revenues. The argument by many economists and the Democrats is that that is not the case, that we are actually to the left. This is an empirical question well beyond the scope of this course, but I hope that the results that we're going to be developing are going to give you an insight of what are the key empirical parameters that would allow you to answer this question and make up your mind when you vote on the upcoming elections in the US or in your own country. One very easy way of seeing what is the redistributive impact of the taxes is to write the net tax that a person of type theta I pays. And notice the following: this person gets a transfer equal to tau 1 minus tau gamma square c theta bar divided by c. So this cancel. The top was the total revenue we just calculated. And it also pays taxes minus tau, of rate tau, on its labor income, which is going to be 1 minus tau gamma square theta I. We also calculated these things before. So if we do the algebra, we get that this is equal to tau 1 minus tau gamma square of theta bar minus theta I, which implies that this is greater than 0 if and only if theta I is less than theta bar. In other words, when you introduce the policy, everybody with a theta I below the mean theta gets a net transfer, and everybody above, let me grab this for you, so if this is theta bar, people here get a net transfer from the policy, and people here get a net tax. Now let's investigate the impact on the taxes on inequality. As before, we're going to do it on the left-hand side for income and on the right-hand side for utility. Let's begin with the case of income. Now we know that the total income of the consumer after the policy is going to be equal to 1 minus tau square w square, which in equilibrium is gamma square, theta I. But he's also going to get a transfer. So this is the post-tax income, wage income. But he also gets a transfer equal to tau 1 minus tau gamma square theta bar. Okay. and this is just the transfer. So notice one thing, if we plot this income as a function of theta I, what we get is the following, that now even if theta is 0, it doesn't start at 0, it starts at tau, 1 minus tau gamma squared theta bar, and then it increases with a slope, this is the income, 1 minus tau squared gamma squared. Okay? That slope is positive as long as tau is less than 1. Notice for comparison what happens when tau is equal to 0. In this particular case, the income starts at 0 and increases like this with a slope gamma squared. So this allows you to see very quickly and intuitively what the tax is doing. Is reducing the inequality and by increasing the minimum guaranteed income and flattening it out. And in fact, if you compute the variance of this, what you're going to get is that the variance of income I is going to be equal to the variance of this plus the variance of a constant, so it's the variance of this, and then we can take out the constants from the basic formulas of variance, and what we get is 1 minus tau to the fourth, gamma to the fourth, variance of theta I. And as we saw before, when tau is equal to 0, we get the previous case as it should be, the case of no taxes, and then the variance goes to 0, and income is fully equalized only when the tax rate is 100%, which is pretty intuitive. Now let's do the case of utility. Substituting from what we have derived so far, the utility of person I as a function of tau is going to be equal to minus 1 minus tau squared gamma squared theta I squared over 2 theta I. That is the effort, or this utility of L, plus 1 minus tau squared gamma squared theta I. That is going to be the labor income, post-tax income. And we're going to have another term for the tax, for the transfer, just as before, tau 1 minus tau w squared theta plus, and this is just the transfer. And remember, from the utility, the Q minus PQ drop out because of the equilibrium price equals to 1 that we just saw before, so we don't have to keep track of that. Now, if we do the algebra, this is going to be equal to 1 minus tau square w squared theta I divided by 2 plus 1 minus tau, I'm sorry, the gamma is gamma square, gamma square average theta. Notice that if we compare the total utility with the I, there is this factor. It's the same except for this factor of 2 in which things are divided. And there is an important intuition for why that is there in the utility, is because when you get income, you also have to pay the cost for it, and that has the net utility that the income gives you. When you just keep track of the income, that factor of 2 is not there. Now, if we do a little bit more algebra, so with more algebra, this is going to be equal to 1/2 w squared 1 minus tau of this term theta I plus tau 2 theta bar minus theta I. Now, if you can compute the variance of the UIs induced by the tax very easily from this middle expression, since the right hand side is a constant and this is almost the same thing as this. What you're going to get is 1 minus tau to the fourth, gamma to the fourth, divided by 4, the variance of theta I. So as before, the variance in income and the variance in UI are extremely closely related, except for this factor of 1/4. One final comment about just this slide. This formula is going to be very useful in the practice problem that you are about to encounter. Now, what's the bottom line of what we have found in this video is that if you introduce taxes, you can reduce inequality, point number 1. But point number 2, you cannot fully decrease inequality, because if you to do so, as you can see in these formulas, you will have to bring the tax to 100%. But in that case, people will react, as we saw in the Laffer curve, by not working at all, which will be self-defeating. So there is a behavioral response to the tax that really introduces a limitation to your ability, or the government's ability, to redistribute. And point number 3, I hope that this is obvious to everyone, there is an inefficiency. Because of the behavioral response to the tax, again, individuals are cutting their supply of labor from what would be optimal, because they only get a fraction of their wages.